Comparative analysis of intercooler performance for HDI and two other coolers. Welcome to our thermal conductivity analysis of intercooler performance. Today, we're examining three different heat exchangers to understand their efficiency in real-world conditions. We'll be testing intercoolers for Mazda Beat 53.2 liters. 1. An HDI aluminium intercooler, weighing 6.4 kilograms. 2. Brand A, with a black finish, weighing 8.7 kilograms. 3. Brand B, with a silver finish, weighing 7.6 kilograms. Our controlled experiment involves heating each intercooler to 160 degrees Celsius, then cooling it to 22 degrees Celsius. We'll measure the time for each process and observe heat distribution using thermal imaging. As we apply heat, notice the differences in heat distribution. The HDI model shows heat concentration in the core, while the other two exhibit heat buildup in the tanks and uneven distribution across the core. Our results show HDI reached 160 degrees Celsius in just 1 minute 49 seconds. Brand A took 2 minutes 22 seconds. Brand B required 2 minutes 46 seconds. For the cooling phase, we used a fan generating a 40 km/h airflow, simulating real-world conditions. The cooling results are as follows. HDI cooled to 22 degrees Celsius in just 2 minutes 26 seconds. Brand B required 3 minutes 11 seconds. Brand A took 5 minutes 2 seconds. These results highlight several key factors in intercooler design. Here's a table showing the cooling time, heating time, and relative performance for each heat exchanger. Note: heating and cooling speed percentages are calculated relative to HDI's performance, which is set as the baseline, 100%. Key observations. 1. HDI demonstrated the fastest heating and cooling times that display a superior heat exchange property. 2. Brand A, despite being the heaviest, heated up faster than Brand B, but took the longest to cool down. 3. Brand B had the slowest heating time, but cooled down faster than Brand A. Efficient heat transfer is crucial. An intercooler should act as a heat transfer device, not merely a heat sink, unless it is used for a short duration at a time. Material and design significantly impact performance. The HDI's aluminium construction and optimized design contributed to its faster response times. Surface coatings and color can affect heat retention. Brand A's black finish may have contributed to its slower cooling rate. Mass influences thermal response. Heavier units generally take longer to heat up and cool down. It's worth noting that HDI brings over 3 decades of heat exchanger design experience to their products. If you'd like to see more in-depth explorations of intercooler technology, please leave a comment below. Your feedback will help us create more detailed and informative content in the future. Don't forget to like, subscribe, share, and hit that notification bell to catch our next awesome test. Until then, keep your engines cool and your performance hot. HDI design, test, and manufacture.